Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 02 part 3. Student, in part 1 basically we discussed the minimum concrete cover requirement, and then in lecture 02 part 2 we discussed the selection of steel bar. In present lecture we will discuss the maximum spacing. Right, as you can see here in this diagram that we have bars, and what should be the maximum spacing in between a bar in a one layer, which is denoted by S max. Now this is very important. We will discuss this S minimum in coming lecture, but in today's lecture we will see what should be the maximum value of this spacing, and we will explain this with some ACI code criteria and with an example. So let's start. Now this is the slide which we cover in this example, in this lecture. You see the distribution of flexure reinforcement. So whenever we are distributing the steel bars in a given layer, there are some ACI code limitations that what should be this spacing, what should be the maximum value of this spacing, and what should be the minimum value of this spacing. This is important. The value of this maximum spacing, which is defined by the ACI code in SI units, is 380 into 280 divided by Fs minus 2.5 cc, that is the concrete cover. We should either choose this one if this value is less than this part, so we will select this one. If this is greater than this one, then we will choose this part. While in US customer units, this equation will be used like in this shape: 15 times 40,000 divided by Fs minus 2.5 cc should be less than or equals to this. It is permitted to take Fs. Now, because as you see in the previous example, like in our review problems, we have to find out the exact value of Fs from the proportionality. But here ACI code permit you that you can choose Fs equals to 2/3 of Fy. This is the ACI code limitations. You can use this for simplicity to make simple the calculation, where Cc is the clear cover from tension phase to outer phase of flexure. I have already discussed this in part 1. Now you can see here the complete detail of these equations, and here you can also see here, and here in SI units you can see for 280 which is around about MPa steel, the S max value is 450 millimeter. Is similarly for 420, 280 is around about 40 KSI steel, and this is 60 KSI steel. So I will discuss these in my coming lecture, that how to convert this and what should be the equivalent value of 280 420 in US customer units, right? So now here you can see the ACI limitations and the ACI code reference in 2005 code. It is explained here that the spacing of reinforcement closest to the tension phase S shall not exceed that given by this equation. This is the ACI equation, and here it also explains that you can, for simplicity, you can choose Fs equals to 2/3 of Fy, and here is the comment section where you can understand these sections, which have, you can say this is a detail of these sections. Now the rule of cracks, remember why we are enforcing these limitations, that the spacing should not be more than this specified value. This is all to control the crack width, right? So here you can see here, most of the time we can say the corrosion is caused by the width of the crack, which is divided from the bottom of tension face. Now once this crack developed from the bottom side, it will, with the passage of time, this crack will widen, and it will causing the corrosion. Now there is controversy in research whether this crack width is important or not important. So you can read these statements and you will see the detail what research says about this. Let's see. You can see this example. Checking the distribution of reinforcement in a beam. At the point of maximum positive moment, a beam contains the reinforcement shown in figure. The reinforcement has a yield strength of 60,000 psi. In this distribution satisfactory. Now, the question is this, that whether this distribution is satisfactory or not. So here you can see the distribution in this figure, right? You see here there is bars 2 number 8 bar, and here you can see 3 number 9 bar. So we have to find out these clear cover, and this cover is from the face to the face of the bar to the face of the concrete. So how to get this? This is ACI criteria. This clear cover CC must be equal to 1.5 inch, and similarly this bar is number 3. So adding number 3 bar diameter 3 by 8. So what we get here, you can see here it is 1.5 plus 0.3, it is 1.875, and right you see here. Similarly the side cover, because I already mentioned this in my lecture 02 part 1, that's both bottom cover and side cover is important, and we will discuss in later, right, in coming lecture. So similarly here it is also from the side, it is also equals to 1.5, and adding this bar diameter size we get the same cover right here. Side cover is also the same. Now as I already mentioned that to make simple the calculation, we will choose Fs equals to 2 by 3rd of Fy. So that by 0.67 to multiply by Fy, we got 40,000 psi. Let CC be the clear cover from the nearest surface, and we calculate CC. Now we will plug all those values, as this is constant. This is the formula value. This is the Fs value which is we got here, and this is 2.5 is constant. This is CC. We got here 10.3 inches. Now from the second part we got 12 inches. So ignoring this one, and we will choose this one. Now this is my S max, which is 10.3 inches. So 10.3 inches is the maximum spacing that shows that the spacing between this bar, this is the clear spacing, and this bar. So this spacing, let's say this is S. This S should not be greater than this specified S max. So we can find out this spacing is. Let me find out this, that this spacing will be how much? This is S equals to 12. This is 12 minus 2 side cover 2 times 1.875 minus number of bars. We have in lower layer we have 3 bars, so that by 3, and the diameter of this 9 bar, that is 9 divided by 8, and it should be divided by the spacing. So we have 2 spacing, so that why we have to divide it by 2. So if you use your calculator, you will find the 2.437 inches, which is less than S max, so the spacing is okay. Remember, there is minimum, there is some limitation that this should be greater than S minimum, but should be greater than S minimum and should be less than S max. So it is greater than, so it is less than S max, but on the other hand, we have to check in the coming lectures what should be the S minimum, what should be the minimum value of the spacing right here. Although this time I can just simply say that this S minimum according to ACI it is equals to 1 inch, or it must be equals to diameter of the bar, or it must be equals to the maximum size of aggregate. That aggregate size can be passed through this space. So this is ACI criteria, but we will discuss in coming part that what should be the S minimum value, right? So this is all about this lecture, that what should be the maximum spacing, which is calculated by using this equation, and we will cover one example over it. So we will use this check in design examples, so you must understand this. Thank you for watching. See you in next lecture.